All right, I worked on this machine called Agent-T by TryHackMe. It's a straightforward machine, has an IP address of 10.10.207.74. Uh, as a start, I went through this simple port scanning using Nmap, and the result shows that port 80 is open. And if we go to the port 80, it takes us to the admin dashboard, which seems like an intranet than an internet website, because you probably won't like to share this dashboard with random users. But anyways, if you go to the details and the components and the menu, most of the links are not working properly. In fact, like you can see on here that most of the links are having an anchor and not much info about us. But this is our test, it's our lab environment. So we are working on an admin dashboard with a lot of information. And our port scanning showed port 80 open as with a web content. Now, if you extend this Nmap scan to include the version check and script check, we see that PHP 8.1.0-dev version is used, and I can see that also on the Weblyzer, the app I'm using, which is an add-on to the Firefox, shows that PHP 8.1.0 is used for programming. Well, this is something we can explore. So if you type PHP 8.0.1-dev, and you will see a very interesting RCE exploit here. This is dated 2021 June 3rd. Basically, when you are sending a GET request or web request in general, you will have a user agent header. And this user agent header typically shows the browser you are using. In this example, it's a Mozilla 5.0 and details about that. But here, the malicious actors, they included a fake user agent header with 2Ds, which is a backdoor, and that is basically a webhook that's called, or a shell, which allows the client user, the end user, to execute commands, and they can run any system commands. And here is an example of CMD. But basically, this backdoor allows the user to run the system commands and attack the machine. Right? Well, this has been this has been fixed very quickly, and if I'm not wrong, this problem has been detected before the wide release of the new edition. So it didn't turn out as a big shock, but it is an example for us to practice on possible attack techniques. Right. Now, so this is the problem. So we can go back and we can in fact download this exploit and try to explore ourselves on this here. In fact, we will be using this exploit and try to capture the root flag, meaning that we can access the target machine to get the root flag. Right, so I can save it, go very quickly here, and go to CD downloads. Okay, this is the Python script. So I can move it to my TryHackMe folder. And if I go to there, see, so I have the Python folder. So what I can do for the rest, I can use my Visual Studio and play with the um, play with mm, the tool. All right. Okay, so I put it here, and here we have this Python code here. So we have this codes here. We have a while loop with the fake user agent header, which allows us to run the commands we like. All right, so I can just run it. And when we run it, it says enter the full host URL. And the URL was 10.10.2 or 7.74. So HTTP, and then I can paste the okay. So it says interactive shell is opened on that attack or target machine, and I can ask who am I. It will give us the root, and the directory is the web directory where the HTML data is stored. So what we can do is we can search for the flag and capture it. And on this script, on this code, we cannot really change the directories. So it is always there. So in order for us to find the flag, one good option is using this find command, and we can search on the root directory, and we can assign the type as a file, and for the name, we can use flag.txt. All right, if we run this as it is, we will be getting a lot of error messages. So what we typically do is we put this in file indicator, file descriptor, let's go to here, and we direct everything with file descriptor to this dev null directory, which is like the black hole. So basically, in Linux, there are file descriptors. So there is 0, 1, and 2. 0 is for standard input, 1 is for standard output, and 2 is for standard error. So by doing this, we will take in the standard error, which is described by 2, and we are basically redirecting it. So this greater than symbol is redirecting the standard error to this directory here, which is a directory where nothing is stored. So it's basically we are burning the content reaching to this dev./null directory. If we do that, we will get the flag on this directory, so we can just cat it out, flag.txt. It gives us the flag for that challenge. Let me put it first. All right, good. So to summarize what we have done here, well, this challenge was not a confusing challenge. The challenge was easy. The important part here was that this addition of PHP 8.1.0, the developer edition, that had a bug or a backdoor, which allowed the malicious actor to insert a fake user agent header, which becomes a shell or webhook for the malicious actor to run comments or system comments, which will help the malicious actor take the control of the target machine. And this has been fixed, and this has been not a big issue as far as I have seen on the data or news on the public domain.